This is a first introduction to the idea of a trigonometric identity. We're going to use this diagram to explain this. We have a line here of length 1 which makes an angle theta with the x-axis. If we drop a perpendicular, therefore forming a right-angled triangle, and we call this length y and this one x, we can see that this is the opposite with respect to theta, this is the adjacent with respect to theta, and this side is the hypotenuse. We know that sine theta is defined to be the opposite divided by the hypotenuse, which here is y over 1, or just y. The cosine is the adjacent divided by the hypotenuse, which here is x divided by 1, or just x. If we look at the triangle and apply Pythagoras' theorem, we have that x squared plus y squared must be equal to 1 squared, which is just 1. But we can see that y is equal to sine theta and x is equal to cos theta, so substituting in, we get sine squared theta plus cos squared theta is equal to 1. This is actually true for any angle theta. So instead of an equal sign, we need an identically equal sign. Identically equal means equal for any value of theta, as opposed to an equation which suggests that there's a value of theta or values of theta that can be found. So for an identity, any value of theta will work. There is some notation here. Sine theta times sine theta, or sine theta all squared, is written as sine squared theta. This is a notation that you need to get used to. So this is our first identity. Sine squared theta plus cos squared theta is identical to 1.